Hello, everyone, and welcome to another K6 Office Hours. I'm here today with two of my awesome colleagues.
Paul Baylog. Am I awesome number one?
Also number two, I suppose. I am Daniel. Hi.
So, what is a TPM?
Technical program manager. I work between engineering and product, helping both. You don't
Yeah, it's great to
my
have
new
you
role,
back.
Nicole?
I think it's funny. You manage technical programs, but yeah, I've given you enough grief on that.
Yeah, seeing that acronym it always makes me think of from the Office Space movie because they, the TPS reports. So that's, I don't know. It just always makes me think of that whenever I see that TPM.
TPS to me means transactions per second. So transactions per minute at K6.
Oh, there we go.
So anyway, Paul, would you like to talk about this new talk that you're going to do?
Yes. It's actually kind of cool. So next week I'll be presenting on the CNCF webinar. I'll be presenting the K6 operator. My title is Running Distributed Load Tests with the Grafana K6 operator. So it should be pretty fun. I was going to include the link, but it's wider than my screen. So the link. So we'll have to get some shorteners out there, and we'll put them in the show notes. But come support me. Should be fun.
Sounds good. I definitely want to see that. And also, this week we also had a new release for K6 Core. We are now at version 0.41. And I'm going to put the link in the comments as well so you can check out what is new. And in particular, there's a lot of metrics refactoring that's been going on for quite some time. And basically that's supposed to, the refactoring is so that K6 better supports time series, and it also has some breaking changes. If you're using URL grouping, it might be worthwhile to look at how it's going to be working. And if you're also using the VU and iteration ITER system tags, they're now not system tags. They're high cardinality metrics metadata. So effectively, that means that you can't use them in thresholds anymore. And check out the link for more of a description on why that is and what you need to do if you are using those. And also our other colleague, Mustafa, who's been on Office Hours before, said that he's pretty quick. He already has released a new version of XK6 Kafka, which we're huge fans of, obviously, and he's updated the dependency so that now it's using the 0.41 version of K6.
Yeah, and I was going to just mention real quick too, just in case anybody that is using extensions, some of the extensions that were on still the older version of K6 had some incompatibilities from those changes. So we've got PRs up. I don't know if everything's been merged in yet, but just in case, if you're having build issues, it could be related to that, and hopefully they get resolved here shortly.
Okay, great. So let's get on to the topic for today. Danielle, Mr. Transactions per minute.
What's the topic?
At ObservabilityCon this week, they just announced that we have this awesome new integration, K6 times tempo. Do you say times or by?
I just say integration between, but as you prefer, yeah.
Okay, so what is this integration? Tell us about it.
Yeah, so this is integration between K6 Cloud and Grafana Tempo traces, or like Grafana Cloud traces, that mostly tries to tackle this problem that developers and pretty much everyone trying to do load testing, performance testing face, and is that analyzing test run results is pretty hard, right? Like, you are going to get some failures from the load generator. You are going to see that some threshold has been broken. Some request is maybe taking a lot from the K6 metrics and the K6 data. but you have no clue on why this happened, right? If something was happening internally, or what really is happening while you are running your test. So this integration tries to tackle that problem by using tracing data that we think is an excellent type of data to augment your performance results. So that's mostly it, I suppose, high level. Yeah.
So Danielle, I wanted you specifically in this office hours because I know you had a big part to play in how this entire project started. Can you talk about how you came up with the idea in the first place?
I didn't came up with the idea. I know that historically both Powell and Robin have liked a lot the idea of using internal data from internal customers' data to analyze it and improve our results. So I was mostly coming up with implementation, not really that much with the idea. It was something that I built with the Tempo folks, with Mario and Joe, and we built it for an internal hackathon. And from there, right, we keep evolving it, and now it's going to be a real product. That's pretty exciting.
And you were even a contributor on Tempo, weren't you?
Maintainer, excuse me.
Oh, sorry.
Yeah, before the acquisition, I was a maintainer in Grafana Tempo, my free time. Yeah.
Nice.
Yeah, so you were like perfectly positioned between like 1 foot in K6 and 1 foot in Tempo. So it makes total sense that you helped make this integration happen. And I also think it's really interesting that this project didn't even make it past the first judging round for the internal hackathon. And do you know why I think that is, Danielle? I think it's because it's hard to understand.
Yeah, I mean, that hackathon was very early on the Grafana acquisition, so it makes sense that not everyone got what we were trying to do. But I think things have just shifted, right? We're much closer to the rest of Grafana, tighter integrations, and I think we're more aligned on everything. So, yeah.
Or Nicole, were you kind of insinuating that there was some sort of a conspiracy?
No.
What?
No, I mean that as supportive as I am of you, when you first told me what you were doing, I was like, what?
Yes.
What does that mean? I mean, great, but like, how? What? So I would like to, if you'll humor me, explain it in using a metaphor.
Do you mean distributed tracing, right? Starting by something?
Yes, distributed tracing. So the reason that I'm interested in this as a performance tester is that a lot of times we treat the application as a black box. So we might send requests to the application, then get responses back, but it's hard to see what's in that black box. So that is a problem because what if the response that's returned is too slow or it's wrong or something happened? That box, it used to, in the era of monoliths, maybe, that might have just been a service or a huge thing. And now it's like many different services and different components that are talking to each other. So it's no longer enough to just be like, okay, that failed. Now what? Then what do you do? That's the problem. So the way that I think of it, hear me out. Imagine there's a car, and that car has to have like these electronic passes. I don't know, my car does. And you have checkpoints like at tollways so that so that the government knows how much you have to pay for tolls. So that car is like the request that you're sending, that's being sent to the application anyway. And then the car goes from checkpoint A to checkpoint B. And that whole journey is called a span, right? And it's basically, if I understand it correctly, distributed tracing is about finding the path, like where exactly did that car go, and where did that request go, which services did it hit, or where did it spend a lot of time, like where was the buildup in the traffic, for example. How'd I do?
Okay. You're improving. the one that you told me internally wasn't like that. Yeah, I think that's mostly it. Maybe diving a bit more like into the details, like tracing is just another type of telemetry that your applications can expose. Same way you got metrics to tell you like the what, request per second increase, error rate increase, or the what's happening. You got logs for telling you the why. Oh, I got an explanation of why this happened. You need tracing to understand the where, right? Uh, and
Yeah.
more with this complex microservices architecture that a lot of companies rely on nowadays. Also with monoliths, right? You still have modules, even if it's everything tightly coupled. You want to understand how everything plays together and what every request touches to really be able to troubleshoot more effectively and better understand what's really happening. Yeah.
Yeah. So a question for you. You said earlier that this is an integration between K6 Cloud and Grafana Cloud. Is this usable for K6? Just
So
OSS K6?
there are kind of two parts of this, right? There is an open source addition to K6, and then there is a cloud part. The open source addition is all about you have your K6 script, and you can say, hey, for every request, just start the traces, propagate them downwards to your services. Um, you can do whatever you want to do with the trace ID on the K6 side. For example, you can log the trace IDs for the requests that took a lot of time to run, or for the ones that failed, or all that is open source, right? We support a bunch of propagators. We're still working on merging it into core. Right now it's an extension. But on the other side, we're offering like this new product that right now it's in private beta, that will get all this data from K6, all the tracing data from your test run, from your K6 test run, will mix both and will generate insights and useful aggregations on how both behave. So there is an open source part, and there is like I like to think that is just another way we're augmenting our result visualizations page on K6 Cloud, adding more insights, this time from internal data.
Okay. Maybe we should say right from the get-go that this is right now still in private beta, right? At least the cloud part is still in private beta. I think you can already use the extension if you would like, but you're not going to get the cloud component unless you fill out this form. This is still pretty new, so we would like to not just release it to everybody just yet, but if you would like to express your interest and maybe be considered for this private beta, please fill out this Google form and somebody from our team will get back to you.
Yeah, we're really looking for feedback from possible customers on how this might be used and what they really like and what they don't like. So it's going to really shape how this moves forward.
Okay. So Danielle, can you tell us, how does this actually work? How is it that requests are tracked through a system?
So you wanna maybe see a trace, and we can walk through the car example with a real trace. Okay.
Yes.
Sounds fair enough. Let me share.
Do you like my example there, Paul?
Definitely.
Oh no, I think something went wrong with Danielle.
The browser can't access your screen, but I shared my screen like 5 minutes ago.
Yeah, you just did. It's fine. We can talk about it and probably get a lot of things wrong until you tell us we're wrong.
So I got a quick question though.
Yeah.
So we've established that so there's the XK6 distributed tracing, which is the open source component, the extension that get compiled into K6, and then that provides a new I guess the HTTP provider. So now are folks that are going to be enrolled in the private beta, are they going to have to use that are they going to have to import in the JavaScript this other HTTP client?
Yeah, that's the approach that we're following for the private beta. It's not how the final API will look like.
Gotcha.
But for now, just to keep it simple, once it's merged into core, it's going to be probably much more smooth. And,
cool.
I think I'm sharing something.
Okay.
There I see your screen.
We see ourselves.
Can you now?
There we go.
Okay.
Hot
Ooh,
rod.
so this was totally not even planned. See, I'm telling you, Danielle, this car metaphor is going places. Even you
It's
have
so
it.
good.
I agree. Not plans at all. So yeah, this is an application, right? It's in fact an open source demo for showcasing. It's a smart tracing application that has a tracing instrumentation, and it's a rides on demand Uber-like taxi application, something. Um, it's mostly about clicking in one of these business, and we are going to dispatch a virtual car, right? That is going to pick up something from that business. So every request that I'm making here is spawning a new trace. So how does this car look like? How does this trace look like? every every trace has a trace ID. This is a unique identifier, right? That is going to identify this trace. Each trace can be composed of multiple operations. These small chunks that you see here, all these ones. Each one of those operations is called a span. A span is going to have a name. For example, the name of this span is HP get customer. It's going to come from a service. In this case, this span was generated by the customer service, and it's going to have a timing, right? How much it took to process this operation. It can have a wide array of attributes and things, but yeah, let's not dive into that for now. Each span can have relationships with other spans. It can have a parent, right? So, for example, we can see that this is like the root span, the upper one, and it says that our world request took 600 milliseconds. But we can see that this request is fragmented into small operations, right? From multiple services with different timings. So tracing really lets you understand where things happen, right? Which answer the operations that took the most? Where are the problems? It lets you dive into each one of these operations and really dig further into really what happened.
Yeah.
For
And
So,
now,
question, Danielle. Oh, sorry,
yeah,
you go, Paul.
no,
okay, I was just going to ask. So on that, the customer service, I mean, this isn't like magically happening. I mean, customer service has to say that I know how to trace. I'm going to look for a trace ID on an incoming request. I will then associate a span with that request and, and all that, right?
Yup. So you need three things for having tracing. First one is instrumentation. Instrumentation is just something that you're going to add to your code that is going to, let that code be instrumented, let's say, able to use tracing stuff. That process can be automatic. There are auto instrumentation for example, Java, Python, a lot of languages, where you just append something before your program and bam, magically instrumented. Or it can be manual, as maybe people are used with logs and metrics, where you explicitly say, what's a span, right? What I want to measure, how to measure it, how to propagate this information, and all that stuff. You need that. You need, it's pretty recommendable, like to have an agent or some kind of piece that is going to ingest all this tracing data. Maybe drop the data that is not needed, aggregate some that maybe you want to aggregate, and all that stuff. And then you need a backend. The backend is like the nth place where all this tracing data arrives, gets stored, and you can search it. In our case, we are using Grafana Tempo. That is the tracing backend from Grafana that supports looking up for traces and storing them in a highly scalable manner.
Okay, so that makes sense. So you're saying that, of course, that in the metaphor, every checkpoint has to know how to tell whether the car has come in there or not, right? There has to be some agreement as to the standards and the format of that information. So in this case, you were talking about having a trace ID, and that's the trace ID that's attached to the header of the request, right? Is there anything else other than the trace ID that is saved and the timestamp, I guess?
Yeah, there is a bunch of information related with this trace ID. It's usually called context. And this context just gets propagated, right? If it's inside the same service, for example, frontend, you can see that it has multiple spans, right? Probably there are no requests in the middle. It's just a Go code and it's propagating it somehow. So that's one way. But when you have different services that maybe they are in different languages or whatever, and they communicate via HTTP, you need to propagate this somehow. The most common way to do it, for example, for HTTP, is to add it in the request headers and just the next service will pick up this information and continue the trace. There are like propagation formats, so all our services understand the same one. There are a few ones like W3C, B3, and a bunch of them. Most used one is usually W3C, and that just makes sure that this service injecting this information in the request, the other one can unpack it on the other end, right, and continue the traces.
Do you know the background on why it's a B3 is the header name?
So
Why?
B3 is the one that Zipkin uses, and I don't know why
It was I believe it was an acronym or a short name for Big Blue Bird because it was from Twitter.
What? Oh,
Started that, so it was I believe it's Big Blue Bird is why it's B3. So,
okay, that's funny.
Okay.
So, Danielle, you were talking about how like these spans have kind of parent spans and then they're also child spans. Does each one have a different trace ID?
No, each span has a span ID, but all of them are grouped together because they have the same trace ID.
Yeah.
They know that they are part of the same trace. If all these spans didn't have a parent-child relationship, we will see them all like, in the same like line, right? Like they are still part of the same trace, but they are not one inside of another, right?
So to clarify, they have the same trace ID but different span IDs.
Yeah.
Okay. Would this be a good time to ask some questions from Matt? Okay, so our colleague Matt is our technical writer at K6. First question, what is a label? Is it a request header, some other property, or is it something else?
I told you, I didn't understand this question and I still don't understand it. So each span, if he's thinking about labels, like in logging and in metrics, right, where you can search by labels, each span in tracing can have attributes. That is mostly the same as labels, right? You can see here that they have like an ID and they have kind of a value, right? And you can search by these in Tempo. For example, you can search here by the tags, right? Or I want to look at all the traces from some service with some span name with some tags, right? That's what I think when he means labels.
Yeah.
But maybe I'm wrong.
Okay. So it's not a request header. It is an attribute. You can think of it as attributes or like metadata that's attached to the spans that help identify it.
Yeah, they can have, most spans like by standards have like a name and a service they are part of, but they can also have attributes that can also be kind of standard. For example, HTTP requests try to follow this HTTP method thing, HTTP URL, and even spans can have events that are logs, right, attached. The tracing format is quite powerful and structured in that way.
A comment from YouTube, KLDLO says, I would strongly recommend put this cloud K6 by Tempo and K6 by Tempo OSS that would allow K6 users base adoption scale. Well, I guess we're already parts of the same company, right? So it's all Grafana now. Both of those, K6 and Tempo, can be used through Grafana and Grafana Cloud.
Yeah, I'm more with the unifying process that we're trying to do, right? Of getting closer to them. Everything is going to get much more closer. Yeah. I'm not sure if I misunderstood the question, but yeah.
I think it sounds like you already answered it earlier when you said that K6 by Tempo can actually be used in OSS. So you can use Tempo OSS with it as well, right?
Yeah, so there are two parts here again, right? One is the analyzing the data and generating insights. That is the same as we do in Kisses Cloud, and that's going to require Kisses Cloud, right? For now, we're on a cloud tempo, and in the future, other types of tempo, open source or enterprise. That's one side, right? But then there is the other side, just starting the traces, and that's going to be, yeah, it's that fully open source for everyone. The other one
Yeah.
is backend work, right, of crunching data and all that, and it's not something that it's easy to open source.
And I think they were also talking about putting it into Tempo, but really it really has to be in K6 because that's where the request starts.
Yeah, it's the problem, not the problem, right? But once you are like kind of mixing data that Kisses Cloud has with data that Tempo has, makes more sense just to process it in our side. Yeah.
Yeah. Okay, another Matt question. How does the label get attached to each span or node? So those attributes.
These attributes, so depends. If you are using auto instrumentation, this will be automatic and based on whatever the auto instrumentation considers correct. And if you are using manual instrumentation, you can just set here whatever you want. As with login, you can write a message. Here you can set the attributes that you want.
Okay. So would this all be, for example, if it's an HTTP request, would those attributes all be set in the header?
No. So between services, what's propagated via headers is only the context that contains the trace ID
The
and a few
trace
things.
ID.
Not really these things. These things will get shipped from the customer service directly to your tracing pipeline to be stored.
Okay, so that makes sense. So it's the depending on the kind of instrumentation that you've chosen, it could be that the individual services, those checkpoints that the car is getting to, are also kind of tracking all of this information, and they're the ones that are attaching the attributes.
Yeah.
Yeah, and
They're
they are
saying
the
that it's a
ones.
blue car. It's a blue car.
Yeah, the services are
Yeah.
the one exporting the information. Same way as with metrics and logs. Each service will export its own spans. So what you propagate between services is very lightweight and only the necessary information to continue the trace.
Okay. Another question. How does the transaction or group on the K6 side get turned into a trace on the system side?
Let's see. We're working on the API, so I don't want really to speak that much about this right now. Let's see. For now, every request is like an independent trace in K6 open source, but we are thinking about maybe in the future adding support for groups, right, where a bunch of requests needs to have maybe the same trace ID, because you are simulating with K6 a service that will make a unique transaction, right, and you want to have everything on the same trace. But yeah, let's see about that.
So this is really cool because this view of the spans is very similar to like in the network panel on DevTools, right? But it's showing you a different thing. In DevTools, when you're looking at those spans, it's really saying how long each resource took to download on the browser side. But this is all on the back end. Like this is showing what ordinarily wouldn't be shown to it within the browser, right? Because the browser doesn't know the internals of an application.
Yeah, exactly. We can quickly spot, right, that there is a MySQL database, a service called customer, another one that is a Redis, like a cache, right? We can quickly spot what's there and try to dive further, right? Instead of only knowing like the results of things.
Okay, so what are all these? You were talking about different formats. I think one of them is also open telemetry, right? What is the difference between like the W3C one or the Jaeger one or the B3 you were talking about and open telemetry? Is it just a difference in format?
So OpenTelemetry is kind of not sure how to define it. It's a mix of standard implementations, a bunch of things for making tracing easier that is compatible with a lot of things. It's usually what you will use to instrument your application. You just pick the telemetry SDK for your language and you can use it, right? That's one thing for instrumenting your application. And then for propagating the information between services, yeah, there are different propagators developed at different times by different, let's say, personas or folks. The W3C is developed by the W3C standard. I'm not sure how they work, but that's the one that is picking up right now and the one that OpenTelemetry uses by default. And then there are others, right? The one that Jagger developed in the past, the one that King developed in the past, the one that OpenTelemetry has in the past. But, most people nowadays are using W3C just to propagate information on the HTTP request. Yeah.
Okay. And you talked about how it's possible that you don't need to manually instrument your services. What do you have to do for it to be automatically instrumented?
So kind of depends on the language, but for example, I know that for the Python one, I think the Java one, that's for people interested into this, look into the OpenTelemetry website. They have a lot of information how to instrument stuff and get started. For these ones, the auto instrumentation is just running something before you instantiate your application, right? Like some kind of wrapper that is going to append all that magically. Yeah, that's mostly it. It's going to auto-detect which frameworks you use, and it's going to instrument the best way it can. It works pretty well, the ones that I have tried, but still way to go. Yeah.
So in this example, it looks like it goes all the way down to the query, or does it just say MySQL, or does it show the actual query?
Yeah, it's the database. Yeah, it's the database with all the information, right, and the query that it is and all those things.
Oh, so the query is in there as well?
Yeah.
Okay, cool. So how low can this go? What about things like eBPF? Can this go down to, I mean, is there a limit as to how far this can go?
I mean, as long as eBPF is sending the data to, your telemetry provider, or I guess OTel or whatever.
I mean, you can instrument as deep as you want. Meanwhile, you're using the same standards and the same format and exporting this information the same way. You can just instrument whatever, right? There are experiments around instrumenting CI pipelines. So, for example, you're going to get one trace for each GitHub action job execution, right? With all the steps, with timings on whatever happens and all the logs attached. And you can mostly instrument anything if you want.
Another question from KLDLO, asking from another angle, logs. How does K6 and Tempo work along with K6 and Loki? Is there a full package solution with logging and tracing together?
So the integration that K6 has right now with Loki is that you can send the logs from K6 and you can ship them to a Loki instance. That's by default. We have a Loki output. So for example, if you're logging your trace IDs in K6, right, and this data is getting sent to Loki, you could use that, right, to jump to the right trace IDs. Then in the logs panel and all these things, you can leverage both. Yeah, if you need.
Could you go from Tempo to say that, for this trace, let me see all the logs that were associated with that trace? Can you do it that way to kind of drill in?
I know there is a way in the Grafana stack to jump from traces to logs. I'm not really sure how it works right now from the top of my head.
Yeah, so I don't think that there is a way for, I don't think the idea is for Loki to talk to Tempo or vice versa, but it's more like have everyone pipe out or visualize their results in Grafana, and then from there, or another visualization tool, right? And then from there you can start comparing what was happening at the time or something. Everything's timestamped So you could still have a look and see what was happening in the logs or in the traces.
So, do you want to see a demo of K6 cross tempo? We can jump into that.
Sure,
maybe.
but last one question from Elibariki John.
Please.
Does tracing apply to monolithic applications or SOA, service-oriented architectures?
Yeah, I think so. Like,
Both, you're saying?
yeah, I don't think this is only like for distributed architectures or, microservices, I don't know, all that stuff. I feel you can leverage this in any kind of architecture that you have, right? Because there are still going to be multiple moving pieces and a big code base, people having trouble understanding where things happen, right? So, yeah, I feel there is still benefit on adopting tracing.
Yeah, I mean, even from that screenshot, if you look at that again, from the customer service and then drilling down into, it started using the MySQL, and then it also was using the Redis driver. So that's all within one single service. So that could have been one big monolith, but you just define where your span points are, where you're going to have those car checkpoints.
Yeah.
Thanks, Paul.
So that way, then if you have some wonky logic or something where it's like, this might take a long time to do this logic, you could wrap a span around that. So you could, this one certain method or something, you could always kind of instrument that.
Yeah, so I agree with both of you that it's for both monolithic and also this distributed architecture. However, I do think that it's significantly more difficult to accomplish this when you have a lot of components, and also significantly more valuable, because it's just almost impossible. Not impossible, but it just would take a very long time to find out where the problem is.
Yeah.
When the more distributed the architecture is.
That's where it definitely shines on the distributed architectures, because there's so many moving pieces and all over the place and disconnected that the tracing just is a huge deal.
Okay, what did you want to show us next, Daniel?
Demo.
It's cross tempo if you want.
Yes, please. That would be great.
Can you remove my screen and I share another part?
Oh, okay, sure. I unshared it. This is great. We get to ask Danielle all the questions.
Yeah.
Who is Daniel?
And Mustafa's even joined us as a viewer there.
I have to share the window because, I don't know, something broke. I'm not sure what. Can you see?
It's okay. No, we just see nothing.
VS Code?
Nope.
Oh my goodness.
I mean, isn't this what the technical programs that you manage? I mean, he understands the concept of distributed tracing for service-oriented architectures, but sharing a screen. Sorry, Danielle, I'm just giving you a hard time.
Sharing a screen is always the...
Yeah, I totally get it.
So
I'm glad she's not picking on me this time.
Yeah.
Nicole's so mean.
And also, can you also show it in K6 Cloud?
Now I got something going.
Okay, I'll add it.
So, let's say I was going to show this in VS Code and run it, but I can't because I don't know how to share my screen properly. So, just imagine that this is, VS Code, and I'm showing my text editor. So let's say that, we're this company, right, that has this service and wants to load test it, right? Wants to run a test to see what really happens. And we crafted this K6 test that has two scenarios. One smoke scenario, where it's just going to run for 15 seconds with one view, just to, check that everything is working properly. And then another one that is a bit more of the stress type, right? Where we're going to ramp up for 20 seconds, for 25 seconds, up to 20 views, and then down, right? Over the next 10 seconds until we reach 0 views. This logic is extremely simple. We're just calling this endpoint. That is the same endpoint that gets called every time someone clicks one of these buttons, right? We are just ordering taxis for a random customer, in this case, customer 123, because it was easy to remember. Yeah, so we have this, and we run it, right? And we can jump to Kisses Cloud to see what happens. So we can quickly see how there is at least two lines that aren't going as we would like. They are going up. Probably that's not good. We can quickly see here that, if we hover here, some responses took 5 seconds. We can also see it here on the top, right? 5 seconds. Okay, something is clearly misbehaving. We can quickly see here also with this per scenario view that the first scenario was more or less okay during the smoke phase, and then we can see during the stress phase how things started ramping up, right? This latency got out of hand for these requests. Yeah, as I said, requests started taking 5 seconds, right? So we got these test results from K6, this black box data. What do we do, folks? What do you think we should do to deep down here? Which ideas do you have?
Add tracing.
No. You cannot do that. No. I really like how Mark explains this. He crafted this slide for ObservabilityCon, so I'm going to copy it slightly, I suppose. So what can we do? If I'm someone testing this, probably the first thing I'm going to do is go to Slack, post a message and say, hey, this endpoint is taking a lot. Anyone knows, right?
Yeah. And I guess if we didn't have tracing, you would try to do it manually. You would try to find out like where actually does that request go. So it goes to like service A, B, C, then you go to A. What was happening at that time? What is the resource utilization? But you'd have to do that for everything. And that's if there's only one path. But what if it's like, oh, for some times it goes to ABC, other times it goes to AEB or whatever. Then it gets really complicated.
Yeah, true. I like how he proposes in a joke manner, or not a joke manner. Just rerun this script with 1 million views or whatever crazy amount of views you want in production, and the team that yells at you probably knows what's happening. That's another approach that you can take, I suppose.
That's because Mark is a chaos monkey.
Yeah, so I mean, not ideal, right? What we would like to do in this future, right? Like, I would like to click here and keep going deeper, right? I already have like this test run ID with things grouped by scenario, by group. Each request, right? I would like to click on this request and really dive into what was happening internally at each point, right? How was my system behaving? So K6 cross tempo is exactly that. I click here and I will see data from the internal system. What I'm going to share is not the front end that we will have for this. It's just the front end that we have for the private beta. So, to play around with the data and how to display it and all these things. So keep that in mind. But just imagine that this thing that you see here, you can see test run ID, scenario group, or all these things, are what's being shown when you click here, right? When you want to dive deeper into this. So let's say
so
that.
Is the idea that it's going to be in K6 Cloud as well? So both K6 Cloud and Grafana Cloud? Is that the plan right now?
We are under discussions on that to see.
Okay.
Yeah. So we're in the exact same place, right? This HTTP URL, this method, this status on the same test run, same scenario, same everything, right? what do we see here? Just by quickly taking a look, we see something a bit problematic. And it's that, okay, this 2 number means that a span failed, right? So we got 2 types of spans, the ones that were correctly processed and the ones that failed. And we can quickly see how, for get driver, the spans generated by the Redis service with the name get driver, a lot of them failed. Okay, that's interesting. It was not what we were looking for. We were looking for the source of latency, right? Why these requests are taking 5 seconds, but we found something else. Okay, let's give it a look. So I can click here and keep diving, right? I can see how all the times this span happened, how it behave over time, over all the duration of my test run. So I can see at every point of my test run how many happenings of this span we have with the count, and how much those spans took, right? We can quickly see here that the errors are constant during the test run, right? They are like 40 something all the time. They are errors that keep happening. And we can click one of these spans. It's true. We can see that, okay, 3 Redis errors here. We can open another one. 3 errors here. Like, it's constant. All the traces have the same amount of Redis errors. So that's probably a problem. We can dive deeper and check in the events that, Redis timeout. Okay, we found a problem, an internal problem that we wouldn't know about, right? If we didn't have this tooling and tracing and everything in place. And we found it. Yeah. Maybe we should solve this, right? Like, there is something misbehaving here for sure.
So it's
but
within
also it's a
thresholds or time frame. It still returns okay, but it could be a problem in the future.
Exactly. And also, like, why are we calling this many times Redis? Like,
right.
we see here that we had like 104 requests, right? Why some spans happen only 104 times and some operations just happen, wow, crazy times, like 10 times? Maybe we can optimize that, because even if they only take like 51 milliseconds, right, on average, maybe, having 1,000 of them is going to be problematic, right? So,
but also it tells you, like, because it said that the errors were in Redis, it narrows down where you need to look. And also the timing of it, this is where it's really useful to be able to correlate data from different sources, because according to your K6 Cloud script, the stress test and the smoke test were running the same request. So this meaning this is not something that happens when it's low load. This timeout happens because as a direct result of the load, because we didn't see it happening for the smoke test. So that already indicates some sort of maybe resource issue, like a utilization issue, perhaps, or something load related.
Exactly. Yeah. Just by looking at this, let's say that I'm not familiar with the system, I can quickly spot, everything. I can quickly spot the different services that there are. Like, I can probably understand that MySQL is going to be the database, right? I can see that some spans failed, some not. How many times? How much they took? And that's critical, right? Because that's what we were researching. Why this takes 5 seconds? So, easy. We can just go here to this column and, P99, order by time spent, right? We see that a few spans take 4 to 5 seconds. Okay, probably we should research these ones, right? To see what really happened. So I click here and I can see something pretty interesting. Keep in mind that this is only data from the stress dispatch test, right? If you remember, this stress scenario was climbing the load for some time, right? And we can see here a pretty interesting pattern, and it's the span duration, the time it takes to process this operation, right? This HTTP get dispatch thing keeps growing, right? Keeps growing as our test climbs view-wise. So we can do something here. We can just pick one request at the start, and we can pick one request at the top, and compare what's happening here. Why at the start of this scenario this only takes a few milliseconds, and one day takes 5 seconds. So we can see that at the start looks everything kind of normal, right? We see also some problems with Redis and maybe this strange pattern between frontend and root, but that's for another time. But everything seems kind of normal. But what happens when we open the other one? Oh, okay, I see that MySQL is taking 4.48 seconds. And as Nicole spoiled before,
Oh, sorry.
we can see that this query is the problematic one, right? Okay. But not only that, we can even see the logs attached, and that waiting for log behind. Right, there is a log somewhere, maybe on the client, maybe on the DB, and looks like that as the load increases, this log gets, locked. Someone is taking it and is just taking too many requests at the same time, so requests are getting delayed. And we found the source, right, of this problem, why it was taking 5 seconds to process these requests. And it's something that you wouldn't be able to do without this, because even if you can go to the tracing data and try to research what happened, right, just by querying it and trying to find things, what if it's a shared environment? Be testing, be production. What if, you have many scenarios, many groups, many types of requests, like things can just go crazy, right? With this integration, we're trying to streamline that. We're trying to, enrich the results visualization page with all this internal data. What I'm showing here is just the start. Is, as you can see, a few metrics. These metrics are Prometheus metrics, so you can do all the crazy things that you can do with Prometheus metrics. But as I say, we want to go farther in the future. That's pretty cool, I think. That was the demo.
Oh, it was great. So I know that tracing has already existed even before it was connected to the actual load testing tool. What is the value of starting it from the load testing tool as opposed to doing it without that?
Right. So the value in our case is that we can build this. That wouldn't be possible to build if the data was if the traces were not started by Key6, right? Because if Key6 starts the traces, it has complete information about each request, right? On which scenario it happened, on which group, it has all this information that you can later on aggregate by, as we are doing right here. Yeah, I would say that's the main benefit, right? If Key6 is instrumented, can just do cool things with that data, and correlate everything end to end.
Yeah, and it's with the response time, for example, K6 already had, it had timings for different components of that. So it gives the entire HTTP rec duration, but it also gave the time it took for handshaking, or, there were different metrics that comprised that total HTTP rec duration. And then on the application side, tracing was already also happening, but there was really nothing to link the two, which is a shame.
Exactly. Here we got all the internal timings, right, for all the requests, aggregated and over time. You can just quickly jump from here right into what was really happening and try to fix your stuff and go back to building new features that, it's a cool thing.
Okay, so what are the plans for the future, where this is obviously going to be changing since this is just a private beta? As people test it, I imagine you're going to be adding new features or fixing issues or whatever. But are there already any features on the horizon that you'd like to start working on?
So I think the main priority is getting, as you said, right, getting these out to customers, trying a private beta, see what they like, what they don't like, if aggregations make sense, if it's useful. All these, questions that we still have, we already have answers for some of those, but we want more feedback. I think that's the right way of building products. Ideas for the future. Not only Prometheus metrics, let's say, getting more clever insights, right? The same way we're doing as in other parts of K6. We have this crazy cool tool called Performance Insights. I would love to see this data applied in there, not roadmap assurance or anything, just a personal liking.
I think that was a guaranteed, don't you think, Paul?
Yeah.
Next week.
I think he said it would be here next week.
Yeah, like
Very
for me,
very soon, end of year maybe at the worst.
I think next week. Now, for me, that will be an excellent use case for this data, but let's see.
Yeah. What I would love is right now in K6 Cloud, we get shown a test, and then the performance insight would be like, hey, you've hit your request throughput, maybe do these things and check in these places. I would love to see that for traces. And in that case, you could say like, hey, these 3 services or whatever are displaying errors. These are the errors it's locking at. It could be, it's like a more nuanced interpretation of the result. So you don't have to delve down into each one.
Yeah. And I got a question on that previous dashboard. There was it had the red where it was like the 4-second requests and all that. What defines that color? Do we have something, or is there going to be something where like a customer would define their SLIs, their service level indicators, and then they would say, okay, this is, maybe 4 seconds is okay, I guess. So it shouldn't be red, it should be green. It's I don't know.
That's another feature that Daniel would love to see, but
okay, that's by Christmas, right?
Yeah, for now it's just this is a table in Grafana, so it just has a threshold up for things that take more than 1 second, something. It's manual.
Yeah,
that's for the demo, but I agree that will be extremely cool.
Yeah, no, there's lots
and
of potential.
per service too.
Yeah.
Because maybe, some things maybe you really need for them to respond within 100 milliseconds. But if it's like a payment gateway or something, maybe you can be a little bit more lax.
Is Mark on the chat? This has turned into office hours into roadmap future for,
Yeah.
Let's invite them on screen. Yeah.
Yeah. So Danielle, also, I know that it's not just you working on this, right?
No, and in fact, most of the credit for this demo and for everything that I have shown goes to Mark, product manager of K6, Wei, product marketing manager. Mark not here, and Lucas. Lucas is the main engineer lately working on this, and he was able to get the project into a crazy state. So
yeah. And
they are the heroes here, not me.
Yeah,
and
I mean, are we hiring for somebody to work with?
Paul got it. I was waiting for Danielle to get around to it. We are hiring. We are looking for someone to help us build this thing.
Yes.
So this is actually an ad. Click on it in the comments. This is an ad for a Golang engineer for K6 Cloud in particular to make this entire experience better. You'll be working with Danielle, right?
And with Lucas. It's a tiny team, but pretty cool what we're working on, I think. Really, really exciting.
Yeah. Oh, Danielle, what is this person is going to be? Can you talk a little bit more about the role?
So the role is kind of a backend engineer role, touching mostly everything. We have a pretty cool architecture to crunching all this data from Tempo and K6. It will be mostly working on that, but just shaping in general the direction of the product. It's not green file, but it's almost, right? We're very early on the process of developing it, so anyone will have a lot of freedom on how to shape this and just change how to analyze performance tests that right now the experience lacks a bit in some regards, right? So I think it's a pretty cool challenge to try to solve.
So if people want to know more about this, where can they go?
We have a blog post. Thank you for guiding this conversation, Nicole. I forget about more things. Finding the
Nicole
blog
is
post.
I do
professional.
have it in the description already of this video on YouTube, so you can have it there. But I can also post it in the chat so that you can go read a little bit more about it. Danielle wrote it.
Thank you, Nicole. And wait, wrote half of it.
And Way as well. And then also, if you decide that you want to take it further and want to be considered for the private beta, then you can fill out this form and you'll hear from one of us shortly. Danielle will personally answer your messages.
One by one.
Okay. Well, thank you, Danielle, for coming on to tell us about this. It's been awesome to see this grow from like just some weekend hackathon project to like an actual project that is going to be a product, that is a product. So congratulations on that.
Thank you, Nicole, and thanks for inviting me. Really happy to be here, as always.
All right. I guess thank you for watching, anybody who is here, and everybody have a good weekend. See you next week.
Bye-bye.
Bye.
Bye.